Welcome back, Math 20-2. So today we're looking at the first half of radical equations. This lesson is going to be quick since there's the quiz tomorrow, and all we're going to be looking at is the restrictions of radical equations. So take a look at this. Consider the radical equation of expression x. Well, I'm going to start this way and help you through this. If I said negative x, so negative 3 is x, what's the square root of negative 3? Or what's the square root of negative 4? I know the square root of 4 is 2, but what's the square root of negative 4? What number multiplied by itself gives us a negative? That's impossible. We cannot find that. Well, what about the square root of 0? What is that? It's 0. So when x is 0, it's 0. When x is 1, square root is 1. When x is 4, square root is 2. So it kind of looks like that. If we were to punch in our calculator, we'll get something very similar. Okay? So now it says, what is the domain of the graph? Well, that's all possible x values. So my domain is x is an element of x is, we're looking at x, where x is greater than or equal to 0. And x is an element of all real numbers. Okay? So then, what is all my defined numbers? Well, x has to be greater than or equal to 0. And x is an element of all real numbers. That's essentially it. It just must be greater than or equal to 0. That's all we're saying. Okay? Why? Because I can't have a negative. I can't square root a negative. That's the key thing. So that's my restriction. I cannot square root a negative. Let's take a look at the next one here. It looks a bit more complicated, but it's not that bad. We want the square root of this, x minus 2. Well, let's take a look at that. When I put 0 in for x like before, now I get negative 2. Can I square root negative 2? No, I can't. So the inside must be at least 0, to square root. That's the smallest it could be. So if I put in 2 for x, I get 0. Oh, so we go there. Then if I put 3, I'm going to get 1. Square root of 1 is 1. I put in 6, I'm going to get 6 minus 4 is 2. Or 6 minus 2 is 4. So I can square root of 2. So now this is going to look like that. And actually, we could even have a negative sign. I'll go into that a bit again later. Okay? So we have this right now. So I know, what is that? X must be greater than or equal to 2. So in other words, the domain for this, here x is greater than or equal to 2. So the expression is x must be greater than or equal to 2. And x is an element of all real numbers. Okay? Because their expression, all possible values, is pretty much your domain. Okay? So state the restrictions. Well, x cannot be less than 2. That's pretty much it. Now, how am I going to decide this algebraically? Well, we take a look at this here. I said that must be greater than 0. So I'm going to put x minus 2 must be greater than or equal to 0. Then I just solve for x. Plus 2 to both sides. X is equal to 2. There we go. That's it. Okay? Let's take a look at this next part here. What did we find before? This must be greater than or equal to 0. So I could put that in my calculator, and I'm going to get something that looks like this. Okay? How do I know that? Well, how do I make this equal to 0? If I 2, what do I double to get 3.5? 1.5. To get 3, 1.5. That's how come I know this intercept's 1.5. If I put in a positive number, if I said 5x plus 5 is 4x, that's 3 minus 10. Uh-oh. 3 minus 10 is negative 7. Can't do that. If I said 3 minus 10, or 3 plus 10, so if I said x was positive 5, that's square root of 13. I could do that. So let's take a look at this. We're going to state the restrictions, and I'm going to do it algebraically. Just skip ahead and do it algebraically. So I know 3 minus 2x has to be greater than or equal to 0. So this is negative, so I'm going to move that to that side. So I'm going to get 3 is greater than or equal to 2x. Divide both by 2, because I want my things to be positive. So I get 3 over 2 is greater than or equal to x, which is the same as 1.5. All right? So here we're going to just do our first example before you do the first question or two in the book. So it says, algebraically determine the restrictions of each of these. So the restriction, all that means is we have to look at this. That cannot be less than 0. So then x minus 2 must be greater than or equal to 0. X is equal to 2. Let's take a look at the next one. 4x plus 1 must be greater than or equal to 0. 4x must be greater than or equal to negative 1. Let's subtract 1 from both sides. Okay? Now I divide both sides by 4 to isolate for x. X must be greater than or equal to negative 1 over 4. Look how that works. Let's take a look at this next one. All we care about is what is in the house for our restrictions. This number doesn't affect my restrictions, only what's inside the radical affects it. So here we have 2 minus 5x is greater than or equal to 0. Well, I want my x to be positive, so I'm going to move that over. So I'm going to plus 5x to both sides. So I get 2, 5x. Now I divide both sides by 5. And I'm going to get 2 over 5 is greater than or equal to x. So in this case, x must be less than or equal to 2 over 5. Last one. Now we're looking at a cube root. Can I cube root a negative? If I said negative 2 multiplied by negative 2 multiplied by negative 2, that's 4 minus 2 is negative 8. So in this case, can I cube root a negative? Yes, I can. So this one is all possible values. So this one, x is just an element of all real numbers. Okay? So that's everything for the first part on restrictions, and I'll continue the second part here in the second video. This is the only part that we need for tomorrow for now, as we work on it, as you have the quiz tomorrow. Good luck, and I'll see you tomorrow.